Hello everyone, in this video I'm going to demonstrate the code and write back unit. Let's get started. I already attached register file with its associated circuits, actually decode and write back circuits. But before we see the overall behavior, let's test register file first. Okay. So here we have a register file with 4 inputs to write and to specify read register and write register, and also output data here and input data here for read and write. Okay. So since it's a register file all initialized to 0, so currently we see all zeros here. So let's play with writing first. So I'm going to write 1111, which is F in hex, to the register ID 1 here. Okay. So this is the test M register ID, and this is the value we are going to write. And then in using val M, okay, sorry, this is typo. It should be val E. Let me quickly change. So val E, let's try to write just 1, which is 3 in hex, and then to the register 111. Okay, then let's click once. Okay, after one cycle, we don't see any changes, but that's fine because we just, so here the output data, like data coming out from the register, is also all register both 0 and 0. Okay, so to check whether the writing is done correctly or not, we need to read first. Okay, so let's write register 1 through source B, and let's write register 1117 through source A. Okay, it looks good. So we wrote 1111 to register 1, and then when we read register 1, then okay, we see 1111. Okay, this is correct. And also when we write 11 to the register 7, and then when we read register 7, then we see the value 11 here. Okay, it works. Great. And then next, let's after we attach register file and its circuits, which generates correct output, correct input register IDs to the register file, and then see. So I loaded same binary that I used in the first tutorial, which is about assembly to binary translator. So first machine code is 3040, sorry, 30F046000000. Okay, and then in my design, I need 6 cycles to fetch 1 instruction. Okay, after 6 cycles, we are going to look at all the probe values, whether it is having same correct value or not. Okay, let's go. 1, 2, 3, 4, 5, 6. Okay, we're done. Okay, let's start with let's start with the produced the value from fetch unit. So first, its instruction code is 3, correct? Instruction code is 3, right? And I function is 0, right? And then RA is F, correct. And also RB is 0, 0, correct. And then constant value or immediate value is 0, 0, 0, 0, 0, 0, 4, 4, 4, and 6. Okay, correct. So note that this is, since y86 uses little endian, when we read this data, we need to swap. And also next, after fetch unit collects this useful information, then we update. It calculates one of the candidates of next PC value. Okay, so what is next PC value? Which is this candidate, which is a val p, which is PC plus size of current instruction, which is 6, and the current instruction is 0. So 0 plus 6 is just 6. Okay, this is 6. Correct. Good. And also it just going back to the PC value, PC register here and here. Okay, good. Then then we checked fetch is still okay. And then let's see these input files, which is generated by this is small boxes. Yeah. Okay. So first, source B. What is source B in our case? Source B was 0, but it is FF 1111 F, but it is correct. Why? Since RB is the destination and we want to write data, immediate data 000046 to this register 0. Okay, so but this source B actually one is going to generate a register ID which we want to read. Okay, but we don't want to read, so we just write 1111. Okay. Okay, fine. And then RA, next RA. So we don't want to read, we don't need to read RA register. So it is 000. Sorry, 1111. Correct. And what about test M? Test M is actually like whether we want to read RA, whether we want to write data to the RA or not. This is RA. Okay. But in this what's that instruction, actually it is IR instruction, we don't want to write data to RA register. Okay, so it is 1111. Good. And then test E, which is RB, and it check if this instruction wants to write data to RB register. And yes, right? We want, since it is RI register and we want to write immediate value to the RB register. Okay, so then this part is actually 0, 0, 0, 0. Okay, there is another typo. This, oops. So let me change this value, this label to E. Oh, sorry, which one is E? I got confused. Yeah, this one is E, yeah, right. Yeah, then we verified, okay, it works with this machine code we fetched, okay? So your case, you can test with more machine code and then until you feel confident, you can test it. Good. So before I finish this demo, let me tell you one thing that I didn't mention in the previous video, which is about control signal on this logic. So what I'm saying is this, oh, sorry, this condition, and this is control signal to this test E. Okay, but you don't have to implement this until we need this, and actually maybe we don't need this for this project. Okay, we are done, and good luck.